So this question we have to do it by the Bode plot as we have done earlier also. As I told you, step number 1, we have to put S is equal to J omega, right? So then we'll get G of J omega is equal to K into J omega square divided by 1 plus 0.2 J omega 1 plus 0.02 J omega, right? So after that we'll have step number 2. Step number 2, as you can see that S square is in the numerator, right? If it would be in the denominator S square, then we'll write down n type of order is 2, but here it is in the numerator. So the value of n is equal to minus 2, correct? And I told you if s is in the numerator and if s is in the numerator, then we'll have positive slope. Okay, positive slope is how much we'll have? Plus 20 dB per decade. Now you can see it's an s square, so again we'll have positive slope, but for that plus 20 is how much? Plus 40 dB per decade. Okay, understood? Now we need to calculate the magnitude at the starting point, right? N value we got it as minus 2. K is the constant, so we can consider K is equal to 1. And we'll start this graph from 0.1. So omega would be 0.1. I told you that depends on us, that we can take omega is 1 for if we start the graph from 1, it will take omega is equal to 0.1 if we'll start the graph from 0.1. Okay. Next, step number 3, we need to calculate magnitude of starting point, correct? So for that we'll have formula 20 log base 10 g of j omega is equal to 20 log base 10 k minus minus 20 n log base 10 omega, correct? So it is how much? 20 log base 10. K is how much? K is equal to 1, right? Minus 20. N is how much? Minus 2. Log base 10. Omega is how much? 0.1. Now solve it and then tell me the value. After solving it, we'll get minus 40 decibel, right? Now step number 4, we need to calculate corner frequencies, correct? Now calculate the corner frequency. See, how can we calculate the corner frequency? Omega C1 is equal to 1 by T1, right? And omega C2 is equal to 1 by T2. If I'll compare with the given format, that is K into S square 1 plus 0.2 S, right? 1 plus 0.02 S. So if I'll compare with the standard equation, that is 1 plus S of T1 and 1 plus S of T2, right? Now T1 is how much? 0.2 and T2 is how much? 0.02. So omega C1 is how much? 1 divided by 0.2 and omega C2 is how much? 1 divided by 0.02, right? So from here we'll get omega C1 is 5 radian per second, and then we'll get this one as 50 radian per second. Got it? Okay, now see in the step number 5, we need to calculate magnitude at omega 1, right? Its formula is 20 log base 10 k minus 20 n log base 10 omega c1. So 20 log base 10 k value is 1 minus 20 into n value is minus 2 log base 10. Omega c1 we just calculated, that is 5 radian per second, 5, right? So now solve this value and then tell me the final value. After solving, you will get 20 log and 1 minus and minus will become plus 40 log is 10 5. So it will become 28. Okay. Step number 6, we need to calculate magnitude at omega C2. So for that we'll have from formula slope from omega C1 to omega C2 multiplied by log of omega C2 by omega C1 plus magnitude at omega C2, right? Slope we don't know, that we'll get it from the table. Remember, log omega C2 is 10 50, omega C1 is 5, correct? Magnitude at omega C2 we got it as 28 decibels, would be 28, correct? Now remember, to calculate the slope we have to draw the table, right? Then only we'll be able to do it. So now draw the table. In the table, first you have to write down the serial number, then you need to write down the term, then you need to write down the corner frequency, that is in radian per second, then you need to write down the slope, that is in dB per minute, then you need to write down the change in slope, that is in dB per decade. Okay, draw the table and then tell me. So first term is j omega square, that is in here, right? And second is 1 divided by 1 plus 0.2 j omega. Okay. Another term is 1 plus 0.02 j omega. So from here we need to calculate omega C1, that is 1 by T1 0.25, right? Omega C2 1 divided by 0.02, that is 50, correct? So now as you can see, it's a numerator. For the numerator we'll have plus 20, right? But it's a square, so can we write down like j omega into j omega? So it is having the slope of plus 40 d per decade. It is the denominator. So denominator having the slope of minus 20 d. Again it is also the denominator, so this slope is also having minus 20 d. Okay, so we'll write down like this: minus 20 plus 40, minus 20 plus 40 is how much? 20, correct? Then minus 20 plus 20, minus 20 plus 20 is how much? 0 12 per decade, correct? Now I told you that which slope we have, like they said change in slope from omega c1 to c. So we have to see the slope of omega c1. What is the change in slope of omega c1 to c2? That is 20 decibel. Got it? So we can substitute the value of 20 over here. Then we'll solve it. After solving, tell me the value. So we got it as 48 decibel. Let's draw the graph based on that. Okay. So as you know, in this we have to plot basically, I'm telling you first for magnitude only. So in the magnitude, as our graph starts from 0.1, right? So suppose this would be 1, 10, 100. Okay. Now this is the omega, that is in radian per second. This is the magnitude of j omega in decibel, right? So it would be suppose 10, then 20, then 30, then 40. This would be minus 10, minus 20, minus 30, and minus 40. Correct? So back to our steps. What is the step number 3, that we got the magnitude at the starting point? We got it as minus 40 decibel. So mark the point because this is our starting point, minus 40 decibel. Correct? Then we need to calculate the magnitude at omega C1. So omega C1 is how much? One is 5 and another one is 50. Right? So mark 1.5. 5 is something here and 50. 50 is something here. Okay? Understood? Now we calculated magnitude at the omega C1, means magnitude at 5. How much we got it as? 28 decibel, right? So 28 is something like at 5 we got it as 28. 28 is something like here, right? So next step is to draw the line. It's a straight line. It's a straight line. Correct? Understood? Hmm? So you can check it from this table also, that first term is square and its slope is how much? 40 decibel per decade. And as you can see, it is moving upward, right? As I told you, if the slope is in the downward, then it is negative. If the slope is in upward, then it is positive. Correct? So it would be 40 decibel per decade, down like that. Next, we calculated magnitude at omega C2, right? Magnitude at omega C2 got it as how much? 48 decibels. So omega C2 is this one, right? 50, and then we'll get 48 decibels, something like we can consider here, right? This is 48 decibel. Now connect this wire, like connect this line. Then another slope is how much? Plus 20 decibel, right? And as you can see, it is again moving upward, so it would be plus 20 decibel per decade. Okay. Now the next slope, as you can see, like we have marked 40 decibel per decade, we have marked 20 decibel per decade. Next slope is this 0 dB per decade. So 0 dB per decade means it's a straight line. Correct? 0 dB per decade is a straight line. So understood? Question now. So this is the simple graph they have asked you in this question, right? Now back to the question, they didn't ask you, like they have gave you one more thing. They said that we have to determine the value of k when gain crossover frequency is 5 radian per second. This k value we have assumed. Now in this we need to determine the value of k as well, right? So see how can we determine the k um, from the graph. They said it's a 5 radian per second. Gain crossover frequencies here, it's a 5 radian per second. So we need to determine this value from the 5 radian per second up to where it goes. Okay. If we'll see it from here, then if we'll see it from the graph, then we'll get it as something 28, right? Because here this point cuts at 28 now. This point cuts at 28. We calculated already magnitude at omega C1 is how much? 28, right? So how will we write down this step? It is 20 log base 10 k is equal to, basically this is the, we got it as a gain margin. Remember I told you this one is the under, this one is the gain margin, so it comes under the negative side, so gain margin will get it as minus 28, right? So if we'll solve it, then we'll get k is equal to 0.04. So this is the formula, that 20 log base 10 k is equal to gain margin. Understood why I have taken negative? Remember I told you, if the gain margin, like if it is in the green range, then it would be positive. If it is above the omega, then it is negative, right? And as you can see, omega is here and it is upward side, right? Then we'll have negative. If it is suppose below side, then in that case we'll have positive gain margin, correct? Last time I told you na, if it lies above omega, then it is negative. If it lies below omega, then it is positive, right? Similarly for this one is the gain margin. As I told you, if it cuts that, I will check it according to. Okay. So in this, they don't ask you to calculate the uh, phase angle plot. Ask you the k value. That in this, according to this k value, the system must be stable. Got it?